now I'm going to explain the software. This is the Arduino sketch that the Arduino runs on. So we start up off the top. We are just importing libraries, so we're importing the library to control the liquid crystal display through the I2C protocol. And also there's this wire library, which is required for the liquid crystal display to work. Here are some variables for the ultrasonic sensor, which pins do what, which pins are listening, which pins are sending out the sounds. And then these variables store numbers. This PTT is ping travel time, which is how long it takes for the sound coming out of the ultrasonic sensor to come back. This PTD is ping travel distance. When listening to the ultrasonic sensor, you get an amount of time that it takes for the sound to come back, but you have to convert that to distance using knowledge such as the speed of sound, and that you have to divide it by 2 because the sound going back and forth takes twice the amount of time as the sound just going there. Then we have the DTT, which is the distance to target. We have 30 as a placeholder value, and I'll explain why after. Now, over here we have LED variables, so this is just which pins the green LEDs are in. This is the timer variable, and I'll explain exactly what it's used for, but it is used in the process of timing the person solving the cube. Over here we're just setting up the LCD, and then over here we have some arrays with, if you recognize, this is cube notation, and this is used to make a random scramble. So we're just setting up mostly what I just explained before: pin modes for ultrasonic sensor and LEDs, set up the LEDs, set up the LCD, and we start the serial monitor because it is used even though we don't see it, since we don't use the serial monitor unless we are debugging, which I had to do a lot of as expected. This right here is for randomness. In Arduino, there's a random seed function that you can use to get random numbers, which is important when I'm trying to get a random scramble. Okay, now into the actual part of the code, no more setup. This right here is just waiting for the user to place the cube in front of the timer. As you can see, it's just waiting for the distance to target to be less than 4 inches. So when the cube is close enough, it will get out of this loop. Next, it is going to actually create the scramble. It's going to generate the scramble. Creating the scramble was probably the most difficult part of the code software-wise, because I don't want to repeat moves of the same type. So R and R prime, which is the right face clockwise and the right face counterclockwise, I don't want to do those in succession. There should only be one R move in succession, or any other kind of move for that matter. So what has to be done here is, first, a random number is generated to decide which kind of move it's going to be. L move, U move, R move, etc. One for each face of the cube. And then there has to be another random number generated to decide which kind of move is it going to be. Is it going to be a regular clockwise move, counterclockwise move, or is it going to be a half turn? So basically rotating that face a quarter of a turn twice. And that's represented as something like R2 or U2. And then, inside of a variable, there has to be a number stored to represent which kind of move we are going to exclude from the next letter in the sequence. So whatever we did last time, we store that in a variable, and then the next time we check if our randomly selected group is that group, we have to randomly select a different group. And that's what this do while loop uses up here. It makes sure not to select the group that we decided not to select while randomly selecting one of the other groups. So it'll print this scramble as it goes on, and well, then the scramble's done and it's printed on the LCD. Then it waits for the user to remove the cube, because remember, all that scramble stuff was done in a split second, in the blink of an eye, because computers are really fast. So then it waits for you to remove the cube so that you can do the scramble on the screen. It waits for you to place the cube so that it knows that you're done. And then, as you can see here, it tells you to inspect the cube. So it waits for you to remove the cube, and then it has to start a timer of 15 seconds for you to inspect the cube. So how this works is we have a constant right here. And I have it as a constant because maybe someday in the future, maybe rules change and it's no longer 15 seconds you get for inspection, or maybe I want to practice with a different amount of inspection time for whatever reason. So I just have this constant here because I'm not going to modify it in the code, but I want a simple place to find it if I want to ever change it. So this is 15 seconds. Now what we have here is a unsigned long of start time. So millis in Arduino is a function that returns to you how many milliseconds the program has been running for. And you can imagine that we can use this variable of how many milliseconds we started the timer at to figure out how long the user has taken. So we store how many milliseconds after the start of the program did the user start inspecting the cube. Then we go into this loop, which is waiting for the user to place the cube. But it's doing a little bit more this time. Instead of just waiting, it's also showing things on the LCD, which you noticed in my demonstration. It has to show how much time you've spent inspecting the cube. It prints inspect, and on the countdown, this is what it shows. Then there's a little bit of math done to determine how much time the user has left. And that is done, to put it simply, subtracting from the original time, which in our case is 15 seconds, how much time has passed since the declaration of start time to now. And we have to convert milliseconds to seconds, of course. Then once time is up, once this countdown variable, how much time is left, goes below or equal to 0, in this if statement right here, then the LCD will print time is up, because indeed, time is up. Now, it will actually keep going, which I will demonstrate right now, and I'll put it on the other side of the screen, that even if you go over how much time you're supposed to use, it'll go into negative numbers, which I think is a pretty useful feature when you're practicing, because often what people like to do is, even if they're out of inspection time, they fully inspect what they're trying to inspect. That way they can see, okay, I need to reduce how much time I spend inspecting by however much amount. And they can see that by the negative number. So then once the user has placed the cube, after they're done inspecting, whether they went over time or not, the red LED will turn on right here. And it'll wait for the user to remove the cube. After the user has removed the cube, it starts the timer, and this timer is very similar to the timer we used up here to inspect. Inside of the while loop, waiting for the cuber to place their cube, it displays how much time is left using the current time since the start of the program and the original time, and converts that to seconds, of course. Once the user has placed the cube and we're out of this while loop, it does the same thing and displays the final time on the LCD. And it turns the green LED off, which was turned on when the cuber removed the cube. Then we just have this while true loop, which will keep going forever until the Arduino resets, which is why you have to press the reset button to solve again. There's a reset button on the Arduino, and I'll show how that works right here to the side. And that way, even if somebody messes with the ultrasonic sensor accidentally, you accidentally bump it or something like that, your time is still there, and you don't lose anything. And then, of course, when the user presses the reset button, you go all the way back to the beginning. Now, if you'd like to see or use or modify this code, then I'm going to leave a link in the description to my GitHub with all my Arduino projects, and this project will be there so that you can use this code yourself.